His Royal Highness Crown Prince Hassan of Jordan arrives at one of his country's open-cast phosphate mine sites. And this is what he's come to see. A walking dragline, built in Britain, erected on site here in Jordan. Capable of stripping away the overburden in giant bucket loads of over 30 cubic meters at a single bite. A machine that will make an enormous contribution to this country's phosphates output. When the Prince steps aboard, he's climbing onto the first machine of its kind in the Middle East, chosen by the Jordanians after exhaustive examination of competitive draglines. The first here in the Middle East, but one of many Rapier W-2000s walking to work on open-cast sites throughout the world. We're going to take a look at the building of one of these machines. Not this one, but a dragline now at work far from the dust and heat of the desert.
In local weather, a 30% chance of rain, 70 degrees out, 21 Celsius. The weather brought to you this time by Smeller.
Clarion, Pennsylvania, is typical of many American country towns. It has a resident population of under 9,000, but it serves as county town to a large outlying rural area of almost 600 square miles. Roughly 4,000 miles from here, on England's Suffolk coast, is the port of Ipswich. Ipswich is considerably bigger than Clarion, with a population of more than 120,000 people. The two towns are essentially very different in terms of size and history. And of course, they're separated by those 4,000 miles. But there is a link. One that was begun in the hills of West Pennsylvania. They call this the Keystone State. The early colonists came here from England, some of them almost certainly from Ipswich. Their spirit of independence is still evident. It's a rich, fertile land, much of it still as the colonists found it. But another industry was added to the agriculture they established. An industry to feed the giant steel mills of Pittsburgh and Cleveland. This is coal country. is the Shannon Mine in Clarion County. In the last 3 years, it has yielded over 3 million tons of high-grade coal. During the next 10 years, its output will be considerably higher because of an import from Ipswich. A walking dragline, a machine that strips away the overburden to expose seams of coal 50 to 100 feet below the surface. It weighs 1,850 tons, and it's capable of moving more than twice its own weight in a single hour of digging. The boom reaches out to an operating radius of 230 feet. When it needs to reach out further to uncover a new section, the dragline simply lowers its feet and walks. It walks on shoes that measure 55 feet 9 inches in length by 9 feet 2 inches wide. On them, the dragline can be moved forwards, backwards, or sideways. The machine is called the W-2000, and it's one of a new range of walking draglines designed and built in England by Ransomes and Rapier. Prefabricated at their factories in Ipswich and Sheffield, and shipped over to site piece by piece.
We had developed a standard range of 5 walking draglines from 10 cubic yard bucket size to 70 cubic yards. In fact, there had been Rapier machines at work in the USA and in Canada for over 15 years. The Shannon Mine people came over here and took a look at us. They bought specifications for the machine they wanted, the overburden to be shifted, depth of cut and so on. And broadly speaking, our standard W-2000 design met their specifications. What's more, we met them on price and delivery. I think they were impressed not only by our design, but by the amount of prefabrication and trial erection that we put into these machines.
The manufacturing program for draglines is such that components are made in the required site erection sequence. Trial erection means jig bolting the components together on the shop floor, a floor which is level to a tolerance of plus or minus 1/32 of an inch. The dress rehearsal is important. The next time some of these parts are mated will be in a North American winter. If they fit here, they'll fit on site. As much of the welding as possible is done here in the shops. This enables Rapier to exercise strict quality control, and it greatly reduces the amount of welding time and consumables needed on site. Working here, the welders achieve a gap between main components of no more than 3/16 of an inch. The Shannon contract had to comply with the complexity of American regulations. The British Standards Institution were consulted by Rapier engineers with regard to federal and state requirements for mine machinery. Components began to leave the Sheffield and Ipswich factories in September '77 on the first leg of their 4,000-mile journey. In the weeks that followed, regular consignments arrived at the port of Felixstowe for shipment to Philadelphia. They were scheduled to be shipped in a sequence that was carefully planned to give the erectors the pieces they want when they want them. During a 12-week period, all of the major components were sent across the Atlantic in 4 shipments. The dragline was being erected at the Shannon Mine, only a few hundred yards from its future worksite. By the first snows, the base had already been erected. It had taken just 4 weeks, 2/3 of the scheduled time, and they were now placing the rack segments which formed the final reduction of the swing gear. 16 cast steel segments, 1.5 tons each, bolted together to form a rotate gear rack 33 feet in diameter. Winter was closing in on them, and outdoor work was becoming distinctly uncomfortable. Consignments were still arriving on site at the end of a 600-mile journey from Philadelphia. Some of them had been delayed by icy conditions on the roads. In fact, this winter was to be one of the coldest in 100 years, with high winds and, at times, a chill factor of 50 below zero. The contract to build the Shannon dragline had gone to Wagner Erection. This is Dean Holbrook, a vice president of Wagner's and the man who supervised site erection.
A few times the snow got pretty deep. And the sites, you have to enter off of a main road up a hill. And we've had to take our equipment, like our pettibones and our cranes. I've even had to get a dozer from C&K to push some of the equipment up the hill, you know, to even get on site to unload it. This winter we had about 18 days, we had a total of 31 inches of snow on site. One day we actually had to take a pipe and probe in the snow to find the boom pipe for, you know, the building of the boom. So we've had our ups and downs with the weather.
Utmost care was taken to establish levels so that the machine would swing smoothly and evenly. David Haig was Ransom's and Rapier's site engineer on this job. He and Dean Holbrook were to live with the machine as it took shape in the coming months. In January, still in the iron grip of winter, they machined the path for the roller rails on which the rotate frame revolves. As spring approached, the snows melted and left behind a legacy of mud. For some men, this was far less comfortable than working in cold, dry conditions.
Rain's worse than snow. I mean, as far as I'm concerned, you can work in the snow and you don't get near as wet as you do working in the rain. You can work all day in the snow and not be near as wet as 15 minutes of rain.
The dragline was beginning to take on a recognizable shape. The boom sections had been welded together, and the assembled boom was pinned onto the upper frame. Towering above it was the A-frame, from which the boom will be suspended. The site welders had benefited by Rapier's policy of doing as much work as possible in the factory. The boom's head and foot structures had been prefabricated in England. So too had tubes been cut to length and prepared for welding back in the works. All of this made assembly very much easier and quicker for the erectors on site.
I was very, very pleased with the boom. The boom went together extremely well. We had less hours than I expected in the boom.
Welding on site was done by certified welders. Every main cord weld on the boom being radiographed and examined for approval by a mobile inspection unit. The site dried out quickly, and it was as if the receding slush had uncovered the bones of some primeval creature. On the right of the boom lies the mast. It was now almost complete and would soon be ready to paint and lift into place. Down on the deck of the rotate frame, much of the hoist and drag machinery had already been installed. They had begun the installation of the swing and walk gears. This is one of the machine's 2 walk shafts which drive the eccentrics. The shafts are made of an alloy steel. So, too, are all of the machine's gears. Most of the gears are in double or single helical form for higher peripheral speeds and quieter running. All the gears have through-hardened teeth, and the forged alloy steel pinions have induction contour hardened teeth. It was now early May. Executives from the coal company looked in from time to time to watch their dragline grow. They wanted it in operation by the end of June. That deadline had been established back in November, and in spite of the rigors of winter, the erection team was running pretty close to schedule. Rapier's site engineer worked alongside them, giving advice and practical assistance. The electrical equipment for drive and control was manufactured by General Electric. 2 main generator units were installed, together weighing just over 80 tons. They'll provide power at voltages up to 600 to all machine motions. The walk motors, synchronized by a Selsin unit, drive the independent shafts which turn the eccentrics. This is one of the eccentrics about to be fitted. The eccentrics are welded steel plate assemblies with alloy steel castings and a live ring of rollers between eccentric and leg. The axles are bronze bushed. With a throw of 2 feet 2 inches, these eccentrics will give a walking stride of 7.5 feet. The squared end of the walk shaft fits into a recess machined in a boss. With 1 eccentric in place, the gears are checked for alignment before the motors are fitted. Two sets of machinery control hoist and drag movements. This is the hoist drum being placed. It is similar in design to the drag unit, except for the grooving in the rope drum. This deck area will be entirely enclosed by a steel housing, which they're preparing alongside the machine at ground level. At about the same time, the painting contractor got to work on the mast. Some 600 gallons will be needed to give the completed dragline its final coat. When it was painted, they picked the mast up and laid it on top of the boom. It was to be pinned into its foot mountings and finally erected together with the boom. It was late May, and the temperatures hovered in the high 80s. Mid-June, the upper frame is complete. Mast and boom have been erected. In a few days, the machine will take her first steps. Now, there's a feeling of anticipation as the system begins to come alive. The dragline was moving for the first time. This swinging action is not just a demonstration of enthusiasm, but to check the seating of the frame on the roller rails. It ran quietly and evenly. The boom is supported by approximately 1,000 feet of galvanized spiral strand cable. Its hollow cords and the rear legs of the A-frame are filled with inert gas. In the unlikely event of a crack developing, it will be detected immediately by a pressure drop, monitored in the cab. The bucket weighs 50 tons unladen and has a capacity of 44 cubic yards. It's said that you could park 8 small cars in it, or perhaps, here in America, 3 compact cars. These final days before the machine walked brought a flurry of last-minute detail to be organized. The Rapier engineer was working now with his American colleague to ensure that everything would be ready on the day. Away from the site, America was looking forward to the 4th of July.
That's it. 10 o'clock news brought to you by Giant Eagle Supermarkets in Shaughnessy, KDK News. Our forecast calling for partly cloudy today with a high in the low 80s. Oh, we've got, let's make it a 30% chance of a brief afternoon thunder shower. Clear tonight with a low near 60 and mostly sunny tomorrow.
June 28th. The culmination of 8 months of site work and the day when the machine has to prove that it can do what it was designed to do.
Okay, we're getting our G reps up there on the MG sets to check out controls. And we're going to take 2 steps off the pad, swing it, physically take a couple of buckets of dirt, swing, dump them, and then we're going to take 2 steps back onto the pad, and then we can finish the machine.
For the first time, the dragline moved its 1,850-ton bulk off the concrete pad on which it had been built.
Like a woman having a baby. This is the same thing to us. You know, you live with this thing for 8, 9, 10 months, and finally the thing is on its own. It walks, it, you know, moves, it digs, you know, and it makes you quite proud.
The dragline took a first tentative chew on Pennsylvanian dirt and then walked back onto its pad. It had performed perfectly, showing a smooth, quiet action. The erection crew's job was done. All that was needed now was to finish painting the machine and then walk it on to its work site nearby. Within 2 weeks of its completion, the dragline was at work for the Shannon Coal Company, stripping the overburden to its full capacity. It had joined the ranks of the many Rapier draglines in mining operations throughout the world, machines which are the prime means of the most economic and efficient recovery of valuable minerals. At about the same time that the dragline began its working life, another erection team had already begun the assembly of another Rapier W-2000. Almost 800 miles south, in the heat and humidity of Alabama.